All right, so trapezoids and kites. Very simple concept. These are our last two quadrilaterals that we have to do before we are done with the properties of all these different types of quadrilaterals. Okay? So, as you see on the screen, your definition of what a trapezoid is, it's a quadrilateral with exactly one pair of opposite sides. So that means that our trapezoid now only, or our quadrilateral now only has one pair of opposite sides parallel. These parallel sides are called bases. Okay? The two non-parallel sides are called legs. Now, if this was an isosceles triangle, then that means the legs would be congruent. Okay? So if it's isosceles, the legs are congruent. Don't be confused that the bases will always be on the bottom. You very well could have a trapezoid that looks like this, where the bases are on the sides. So, take a second, pause the video, and see if you can figure out where each segment, or what each segment or angles matches to the term. Alright, hopefully you got this as your answers. Okay? Remember, diagonals go from one vertex to the other. So that's why 5, those were diagonals. Consecutive sides, remember, they meet right next to each other. So that's why ML and KL were consecutive sides. Of course, you still have opposite angles. And last one, angle M and angle L, they're what you know as base angles, okay? Base angles are located at the bases. If it's an isosceles triangle, the base angles are congruent. And that's what the next theorem says. If you have an isosceles trapezoid, I think I said triangle earlier, I meant trapezoid, then each pair of base angles are congruent. And vice versa. If a trapezoid has a pair of congruent base angles, then you know it's isosceles. So you use that information to help you solve problems like ones here. This is a trapezoid because it has the parallel, one set of parallel sides. But on top of that, it's isosceles because of the congruent markings. So if it's an isosceles trapezoid, we know base angles are congruent. So that means C and D are congruent, and A and B are also congruent. How do you find A and B? Flashback, use a little bit of your knowledge. If these are parallel lines, and AD is a transversal, these angles, this angle D and angle A, are consecutive interior angles, which means that they have to add up to equal 180. So if angle D is 112, to find angle A, all you do is subtract 112 from 180, and you get 68. So angle A is 68, and angle B is 68. Okay? Look at the next one. It's a trapezoid, but it is not isosceles. So you can't say that angle A is 132 like angle B is. But you can use the fact that AD is another transversal because here are your parallel lines cut by your transversal. So angle A and angle D have to be supplementary. So this also has to be 90. Same thing over here, B and C. That's a transversal because these are still parallel lines. So angle C would have to be 48. Pause this video and try number 9. Did you get 77 for angle D? 103 for angle A and B? I hope so. If you did, good job. Now, take a minute to pause this video so that way you can write down this proof. But basically in class we did the proof to prove this next theorem, which says that if a trapezoid is isosceles if and only if the diagonals are congruent. If and only if, remember from our logic unit, that meant biconditional. Get this proof down. The last thing before we move on from trapezoids is the mid-segment theorem, which says that the mid-segment of the trapezoid is parallel to each base and its length is 1/2 the sum of the bases. Do you remember the mid-segment theorem for a triangle? Well, remember, it was parallel to one side and it was half the length. So if the mid-segment was 4, we know the base was 8. Same concept, except this time we have two bases that we have to add and then divide by 2. Let's look at some problems. Here, RT is our mid-segment. So that means we have to take half of our two bases when we add them together. Well, half of 21 is 10.5. So RT is 10.5. Look at the next one. RT has to be half our two bases. Well, it looks like our variable is one of our bases and RT actually has a length. So we're going to plug in and we're going to solve. So we're going to multiply both sides by 2 to get rid of the 1/2. So we get 22 equals 8 plus x. And then we subtract 8 from both sides. So x, the value of our base, is equal to 14. Pause this video and try number 12. Did you get 2? Hope so. Your answer was 2. Look at the setup, same as before, and solve. Try the next few problems on your own, okay? Pause this video and see if you can answer these problems. All right, check 13 through 17. Hopefully you got those answers. I wanted to work out 18 before I actually put the answer up. EF is your mid-segment. DC plus AB equals 4x plus 6. So your sum of your two bases is already given to you. So you should have set it up like so. I went ahead and put in the multiplied by 2 part, which gives me 2x plus 10 equals 4x plus 6. Could you FOIL the 1/2? Absolutely. But since we have been kind of doing it like this already, I just wanted to continue. So then we solve for x. Subtract 2x from both sides to get 10 equals 2x plus 6. Subtract 6 from both sides to get 4 equals 2x. So x equals 2. But did it ask for x? No, it asked for EF. So we had to go in and plug in 2 for x, and EF is 7. And that's it for trapezoids. All right? If this went too fast, it's okay. Go ahead and pause the video, go back, do what you need to. But I want to make sure that you actually understand it.